So here we have the equivalent of a two-link planar robot where L1 and L2 are the lengths of the two components. O is the center of our coordinate system. E is the tip, and we would like to know where E will be as a function of the link lengths L1 and L2 and the angles alpha 1 and alpha 2. Here I've shown angle alpha 2 as the angle that is measured from the extension of L1 to L2. How are we going to approach this? We need to know where XE and YE will be located. We can look at this and apply what we know about the analysis of a single link robot. So what I'm going to do, I'm going to draw another coordinate frame here that has its origin at the joint or the location where L1 and L2 come together. And I'm going to call this coordinate frame X2 and Y2. And this origin where they come together, let's call it A. So if I figure out the distance where E is located in the coordinate frame X2 and Y2, that distance here and this distance here, and if I go back now to the first link and I figure out where this is located in the original coordinate frame, then I can sum those two distances and find the coordinates in the original coordinate frame. So let us write the expressions by analyzing it as triangles. Let us work in the second coordinate frame. By using what we know about parallel lines, we observe that this angle here from X2 to the extension of L1 is equal to alpha 1. So the distance here along X2, so if we want to call it XE2, is going to be equal to L2 times the cosine of angle alpha 1 plus alpha 2. The distance YE2 will be equal to L2 times sine of alpha 1 plus alpha 2. So this is YE2 and this is XE2. This is YE1 and this is XE1. Let us find now XE1. XE1 is equal to L1 times cosine of angle alpha 1, and YE1 is equal to L1 times sine of alpha 1. Notice here that we applied the sines and the cosines definitions, and then I skipped the first step because we've seen it multiple times. And finally, the coordinates of XE and YE for this two-link robot are given as the addition of XE1 plus XE2, and for YE as the addition of YE1 plus YE2. And of course, the next step will be to substitute the expressions for YE1 and YE2 and XE1 and XE2 and find out these coordinates. So XE will be equal to L1 times cosine of alpha 1 plus L2 times cosine of alpha 1 plus alpha 2, and YE is equal to L1 times sine of alpha 1 plus L2 times sine of alpha 1 plus alpha 2. And of course, these expressions have the cosine of the sum of two angles and the sine of the sum of two angles. And if anybody is interested, it can expand this further based on the trigonometric identity that we introduced in the previous modules. So given this information, we are able to know where the tip of this two-link planar robot will be located, as the angle of rotation alpha 1 and the angle of rotation alpha 2 are known. Of course, in this analysis, L1 and L2 must be known. So this two-link planar robot analysis is applied for planar prosthesis, but also is applied to robots that are traditional industrial type robots, such as what we call SCARA robots, if we look at the SCARA robots from a top view, then we will observe that they have this type of motion. They are fixed and rotate about this base point, and then they rotate about this other point. And they usually have two more motions about the last point, but this motion is just a pure rotation or a pure translation perpendicular to the plane of the board. The other type of robots that this analysis is applied is what we call fully articulated or anthropomorphic robots. Anthropomorphic robots are similar to us. They have a torso, one rotation about the torso, one rotation about the shoulder, one rotation about an elbow, and 3 rotations about the palm. However, for us right now, where we are working with these two-link planar robots, we can think of the shoulder of an anthropomorphic robot, of what we call the equivalent shoulder joint, that is connected, and then we have an elbow joint, and then from the elbow we have a connection that goes to the last palm, to the equivalent of a palm, which has 3 degrees of freedom. So as you observe, and if you look in the literature or on the web, the analysis of this two-link planar robot has applications in prosthesis and traditional industrial type robots.